Hi, welcome to an ESP32 tutorial from Robojax. My name is Ahmed Shamshiri. I'm presenting this tutorial from Canada. In this tutorial we're going to learn how we can control one or more servo motors using ESP32 using Bluetooth. For example, right now if I press this button, the servo moves to a preset angle that you wish. It stays there, and when I press it again it returns. One time it moves to an angle, second time it returns back, and it shows here it went to 0, and then next time went to 180, and you can set those values. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. In my all videos, under the video in the description, click show more and you will see the link directly to different section of the video. You can click on any of these links to jump directly to different section of the video. I've seen a lot of interest in controlling let's say a robotic arm or a car or something using your Bluetooth, even a mobile device or tablet, whatever you have. You can control servos, and with ESP32, because it has built-in Bluetooth, you don't need to attach anything else. It's very easy. You just program it and upload the code that I've provided with the library. It will just work fine, and whichever Bluetooth or ESP32 you have, it will work, and just 4 wires and simple as that. So in this tutorial we are just moving a servo from a preset value, let's say minimum of 0 to 180. If the maximum is 180, it will stop, and the next time when you push it, it will come back. So I have other video that this moves and comes back, that is separate, and also I have a video that you can send the servo to a specific angle, let's say 60, 50 or something, and it doesn't do anything else, it just stays there. But this is moving and staying, and then next time it comes back, and you can set specific angle for each servo, and whatever number of servo or input that the device allows, you can connect it up to 16 servos possible to control with this device. But there are a number of pins are limited, so whatever angle you want, you can set upper limit or lower limit for each servo motor individually, and also you can set the step of moving. For example, we can set it so it can go in the step of 5, 5, 5, or 10, 10, 10, or 20 or 30, whatever you want, so it can go more smoother or more faster. And make sure to install the library, and make sure to use it without Bluetooth, just connect it directly to ESP32. So just connect it to ESP32, either this type or that type, it doesn't matter. The one that I have is, it says ESP ROM32, WROM32. So all of ESP32 modules will work fine with this code. Once you are successful with controlling it using just the code to send this to any angle, then come back to this and apply all this, because if you want me to reply to your comment or question, make sure to subscribe and post comment or question. I will always reply to my subscribers. Let me briefly explain the servo motor. Servo motor is a type of motor that the shaft can be controlled to move only 180 degrees, or half a circle, something like that. And then you can control precisely where it should be between 0 and 180 degrees. There are also other types of servo motors that, for example, there is something called continuous servo, which I have the link below. It will rotate 360 degrees and you can control it. But these are the most common one. And also you might get this type of servo motor, which is very heavy with high torque. It is the same way. It can go 0 to 180 degrees and it will stop. So this is MG966R version, and this is the metal gear. This is all metal, and this is a plastic gear, so this will be much cheaper, like 3 or 4 or 5 times cheaper than this. But in general, this is the operation and you can control it. So the servo motor has 3 wires The darker wire is the ground. The 5 volts is always at the middle in case you make mistake in terms of connection in RC or car or airplane. So the middle is always 5 volts, and this is the signal. You might see it as a black wire on this side, red is always red, and this side you might see white, but doesn't matter. So they're the same. Configuration is exactly the same: ground, 5 volts, and signal. Let me now explain the wiring. First, prepare 4 male to male. These are all male to male wires. Align them in the same line. So 4 of these will be used as positive or power for the servo. We are connecting them in here for 4 of them, and then 1 extra here. This is for positive external power. So I have 5 wire here, and then here connect also 4 male to male. These are all for the ground, and then the 5th one is also for the ground. And here are my servo motors. I will start connecting from this side to the positive of servo 0, servo 1, servo 2, servo 3. So I'm connecting it to the positive. The middle wire is positive. That's for servo 1, servo 0. That's servo 1. That's a power for servo 2. And the last one, servo 3. All the positive have been connected. Now I'm connecting the negative from this side, servo 0, 1, 2, and 3. Now all of them, they have second wire. As you can see, the last wire on this side is the signal, the orange. I have this 4 wires here. Is male to female. This side goes to the ESP32. This side will go to servo 0, 1, 2, and 3 accordingly. So I'm going to connect it to servo 0, then servo 1, then servo 2, and the last one will go for servo 3. This is my external 5 volts, the power. I'm connecting this yellow on this side. I'm connecting it to red, to positive. Now I'm just holding them like this and connecting it to pin 12, 14, 27, 26, which are all side by side. This ground from here will be connected to the ESP32, to this pin where I have a ground. And here from my power supply I have to connect another ground to this module. Now I have 2 ground. 1 ground goes to the wiring, 1 ground goes to the external power, because the external power must have common ground with this. In order to start using ESP32 with Arduino IDE, you need to prepare Arduino IDE for that purpose. You will copy and paste it here. You see it says package ESP32 index.json at the end. So once you paste it here, click OK, click OK. This is telling Arduino IDE where to get the board driver. Click on Tools, and then Board Manager. And here, wait for this to complete at the bottom, this bar graph. And then type here ESP32. You see ESP32 by Espressif Systems. It says installed. In your case, it will not be installed. You will have install button here. Click on it, and it will take maybe a few seconds or a minute. And the installation, once is completed, click close. Now we have to tell Arduino IDE which board you're working with, because the driver is ready. Click on Tool, Boards. This is Arduino IDE which you will usually work, but scroll down until you see a line below that. All of these are ESP32, and ESP32 rover module is the one that you click and select, and the dot will appear. Now we have to select the port. For that, we have to find out which port we are using. Right click on the Start menu, Device Manager, and you see port. Click on this arrow to collapse it, and mine is using COM port, Silicon Lab. If I disconnect it now, you will see that it will disappear. Connecting it back. So this is COM6. Note that. Click on Tool, Port, and you will see COM6 is already selected, and now you can write your program and run it. The first thing that you need to do is download the library that I've prepared and fixed. The original library have been taken from this URL, but I downloaded it as a zip file in your computer. Let's say save it in your download folder. After that, go to Sketch, include library, add .zip library, and then point it to the folder you have saved. For example, go to PC, Downloads, and if it was inside the downloads, and if it was the file that you downloaded as a zip, select it and click Open, and that is completed. And then copy and paste this code in a new file, something like that. Create a new sketch and paste it. The code starts from this line, include servo_esp32.h. This is the library, main library file. And here, constant integer servo count 4. If you're connecting 4, 3, 5, whatever number you have, put that number here. And these are the servo pins as an array here with the 4 elements. And these are the pins 12, 14, 27, 26. And these are the pins that are exactly side by side. From here it starts 12, 14, 27, 26. So they are in order. And even in this one, in both cases, this is a USB. The pins are on this side. And in this module, which it looks a little different, but the chip is exactly the same. So the pins are there. Do not worry if it has G, for example, on this. It says G12, G14, G27, 26. But that is referring to 12, 14, 27, 26 without any letter. So in the code, we are entering just the number. So these are the pins. After that, we create from this class, we create an instance of it here, and we call it servos, and with the number 4. So this is initializing it with those pins. And these are the letters turned on that we can control the servos with a character A, B, C, and D. You can type any other character you want as long as you put it inside single quotation. It's very important, otherwise it will not work. And this comma, everything must be the same. You just change this. Whatever character is on the keyboard or in your mobile device, just put that character and it will work. Then here the servo angle, servo step. This is the angle that is holding when you move the servo. And doesn't matter, do not change it. And here the angle, the step, these are customizable for each servo because we have 4 servos. Here we have 4 values. The 10 means every time it moves from one angle to the other, it goes with a step of 10 or increment of 10 degrees. So if you want it to go faster, make it 20 or 15 or larger. If you want it to go more smoother, reduce it. But remember, this will reduce the speed of servo. The minimum is the minimum angle that you want your servo to move. If you want it to be 20, 30, 90, whatever, that is for each servo you can put. And the maximum is also the amount of the value of angle that you want the servo to move. For example, if you don't want your servo to move above 90, make this 90 instead of 180. But if you do not have any preference, just leave it 0 to 180. And this is for servo, first servo, second, third, fourth, and also the same thing, first, second, third, fourth. So these are in order, whatever value you put. This is the minimum for the first servo, this is the maximum for the first servo, and also this is minimum and maximum for the second, third, and fourth. And all of these are array, and I have applied the same method for all. Button pushed is a value that when you push the button on the your mobile device, this on the Bluetooth, the value will be stored here, do not change it. And then received character is a variable that is holding the character that you press on the device. It will be stored here. Full debug equal true. If you put it to equal true, it will show all the angles on the Bluetooth device. If you set it to false, false, lowercase, it will show just the angle and not all the angles. Here include Bluetooth serial.h is used in this case, and it is part of Arduino IDE and also part of ESP32. You don't need to download anything. These two lines checks if Bluetooth is enabled on the device, otherwise they will throw some error on the screen. And we create an instance from Bluetooth serial and we call it serial-BT. And here handle servo, integer servo name. This is a prototype of a function that is at the bottom of the code, which I will explain next. Inside the setup, we initialize the serial monitor with 115,200. That's the text that is displayed on your computer. And Bluetooth serial-BT.begin. This is the name of the Bluetooth device that you assign here, which will be displayed on your mobile device. So this is the device of the Bluetooth name that you search for. And this is just a text on the serial monitor. You see serial, and then we have serial-BT. So this is on Bluetooth, this is on the computer screen. And this for loop goes from 0 to servo count, which is 4. It goes 0, 1, 2, and 3. And I changes, and every time it changes, we attach the servo to a pen. Servo, and then I attach servo pens. So we are attaching, and this is just printing a text for us. And inside the loop, we read this Bluetooth using serial-BT.read. This is called casting. We are making sure or converting it to character, and the value of this is stored in this variable which we've defined at the top of the code. So this is holding the character, and that we are pushing the button at that moment. Every time you push it, it will be stored here regardless for which servo it is, because at one time you can push only one. And this for loop is to check the character against the list that we have. We call it turn on. This is an array here. So we check if it is equivalent to which value, and then we set that button pushed equal 1, so we know which push button is pushed. And it goes very quickly after checking that. Then we check if button pushed is true. I could put I could put here equal 1, but which would be true, but because the value here will be the same, so make it very simple. If it is true, then we say run the servo handle with the I is 0, 1, 2, 3. So this I changes, so it goes to different servo to control it, which I will explain as I said next. And this line will move the servo I equals 0, 1, 2, 3, whatever angle we have set. This angle, this is as if I type, for example, 89 degrees. So we say servo, let's say servo 2 moves to 89 degrees. So the job of this loop is to automatically the value that you have selected will be, the servo will be moved to that angle. And then we give it 20 millisecond delay. The loop will continuously execute these codes. Now, servo handle is a function that I've written at the bottom, and it receives the servo number, and here we check if full debug. We print all these texts. These are serial BT, serial BT. These are printing value on the serial monitor on your mobile device, and these are the serial monitor on your computer. Otherwise it will not print it if full debug is not equal true. So if the angle was 0 and if this was 10 degrees, so 0 plus 10, this plus 10 means this is now 10 degrees, and that's it. So the servo value will change. Now this goes next time and next time. Every time this loops run here, it will go, and we check in this line, we check if it is above the value when it reaches at the maximum. So we do two things. First, we stop it, we change the value, push button equals 0, and also we do not allow it to go above the maximum. Let's say if maximum was 180, we don't allow it because it will give error. More than 180 is not allowed. And also we change the direction by adding this negative sign. So next time when you push the button, the servo will move in the other direction. And if the debug is not set, we also print this. So we print very simple servo number at this angle, and it shows only one time. And this is the opposite. This line was for the bigger or larger value. This is when it reaches back to 0. So we set push button to 0, so the servo stops, and also we change the direction, and exactly the same thing, we print this text. From the Play Store, just type Bluetooth serial terminal. I just type Bluetooth serial terminal, and the first one, the app that you have to get is to get the serial Bluetooth terminal. Once you got it, then make sure go to Bluetooth setting and to the device and connection, and turn on your Bluetooth. Make sure the Bluetooth is on. Search here and search for the device, and you will see ESP32_Robojax. So when you find ESP32 Robojax, touch it, and it will be paired and moved. And the list here, now we have ESP32 under the pair devices. Now leave this, and then let's open the USB32 terminal. Go to this menu and then devices, and then you will see ESP32 Robojax. Touch it. Once you touch it, it is connected now. If I go back again here and devices, you will see it shows green, so it is connected. If I touch again here, and also at the bottom it shows connected, I can disconnect it by touching that point, and you see it is disconnected. So I'm now connecting. It is now connected. Now we have to set the values here on our Bluetooth, these buttons. So hold the button, this menu appears. So let's name it Servo 1, and the value is a, lowercase a, and then touch here. Now this changed to Servo 1. Let's do this the same for all. For Servo 2, select B. For Servo 3, select C. For Servo 4, select D. Now I have 4 buttons here. It says Servo 1, 2, 3, and 4. And for example, if I touch this Servo 2, you see that it says servo move to 180 degrees. And if I touch this again, it comes back. It shows Servo 2 moves to 0, and Servo 3 same way. And inside the code, if you set this to true and upload the code, and now because debug is enabled, if I touch this, the servo moves and you see all the values. Instead of 1, the whole thing is for 1 servo because it's the debug information. Also, for each servo, you can type here the value instead of pushing those buttons. For example, you can say A, and Servo 1 will move. Let's delete it, put B, Servo 2, and if I send B again, it will return C, and then C again. Just send it as many times you want, but if you want to type D, the last servo will be moved. Thanks for watching. This was how to control servo motors, moving them in one direction and stop using ESP32 and Bluetooth. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. So my final external power is connected in here. The positive is connected to this point, which is going to all the servos, and the negative is connected to one of the ground pin of the device. So you have to connect external power, otherwise this will not work.